Okay, hello. Good evening, everybody. Good evening, good evening, good evening. We are here back for another session of Math 102. All right, good to see everybody here today. Thank you very much for coming on out here today. We are going to get started here fairly shortly. Good to see you. I see a few people in the chat already, so we'll get started here shortly. We'll get hopefully a few more people to come on in. At least I think so. Thought I saw a couple people. Question mark, question mark, question mark. Oh, I did. Alright. Get through those thingamajigs. Good to see everybody. Absolutely fantastic to see everybody. I hope everybody is doing very, very well here today. Good. I see. Who do I see here in the chat? I see Bill and Sammy. I see Bill and Sammy here in the chat so far. Hopefully both of you are doing well. Wait for the other usual suspects, I'm sure. Maritza and Sanla and crew. Oh, I see. Strolling, hello. How you doing? How we doing, Strolling? I hope you're doing well. Hopefully we're doing well here today. What am I supposed to do? Play all, yes. Sure. It works. Doing fine. All ready for this Thanksgiving holiday, I hope. Sorry for kind of roaming around here. There we go. There we don't go. All right. We're going to get started here in just a moment here, Strolling and crew. We're going to get started here, and then we're going to get through this lesson here for today, and then we got a big announcement to talk about. So that is the other thing we got to talk about, is our big announcement. I know. So... Okay. Hopefully got a few more people in here now. I think we do. Alright, that's good, good, good. Alright. We're ready to do this, alright? I think we're ready to get started here, ladies and gentlemen. So let's get going here. Let's get moving. And let's do this thing. Alright. Okay. Alright, there we go. Alright. Okay, let's get started today. Welcome back to Tuesday. Hope you had a nice weekend. Alright, this is the only time we're meeting this week. So again, we're not meeting for Thursday for Thanksgiving. Alright, in any case, let's go ahead and talk. We got a couple things to talk about here today. Today, we're going to go over section 4.4. Alright, it was brought to my attention here in my earlier class that I did not put a handout for section 4.4. I updated that on D2L. So there should be a handout for 4.4. It'll be listed as 4344 Math 120 examples. So it'll be listed underneath there. And it'll be some questions in relation to that. Other things to talk about here is that is the section we're going to be doing is section 4.4. So let's go ahead and start talking about it, and let's discuss exactly, well, what exactly we're doing with it. I think that sounds like a brilliant idea. Well, let's go ahead and do it right now. Go to the big board. Let's go to the big board. Oh my goodness. All right. So today, for the past 3 sections in Chapter 4, we were dealing with correlation coefficient, we were dealing with line of best fit, we talked about coefficient of determination. So we've talked about all those things. However, today is kind of like a different point of, this is has nothing to do with the previous 3 sections, so it's kind of put in here. But it does have some things that we've done in the past that certainly do apply. So things that we've seen in the past and have used in the past, we certainly will be using again here in some capacity. So today what we're going to be talking about here is, let's go over each question here. We'll be talking about starting from question 5 here. We'll be talking about what's referred to as a contingency table. Now, what is a contingency table? A contingency table is a table of data with rows and columns that indicates a category with the totals of each written in each column and each row. And this will be able to relate 2 categories together. Let's take a look at an example of what one does look like. So I want to use actually a book example here to kind of showcase exactly what this means. Let me navigate my way back here for just a moment. Alright, so let me show you here on screen what we're talking about. What we're talking about here is a table that looks like this. Alright, this is effectively a contingency table. Alright, notice that this particular table here tries to relate employment status and the level of education. So for example here, are you employed, unemployed, or not in the labor force? Or did you not finish high school? Are you a high school graduate, some college, or have a bachelor's degree or more? Again, we could say, for example here, if we want to relate both of these things, as in this particular table, we could say 10,179 people are employed, but also, and did not finish high school. So, you know, you can relate both here at the same time. Now, if you also see here, we went ahead and I'm going to put this here on a little bit of a half and half. Right? As you see here, we went ahead and added these columns together, and we added these rows together. So for example here, how many people total out of the amount of people we surveyed happened to not finish high school? Hey, Dylan, how we doing? Yeah, don't forget the hashtag, Dylan. How we doing? Um, all right. How many people did not finish high school here based on the survey that was done here? So in total, we have 24,395. I hope you're doing well, Dylan, my man. Hope you're doing well. All right. How many people didn't finish high school? How many finished high school graduate? Again, 61,000, and so on and so forth. Now, you can also add the number straight across here. So again, you can add the 10,000, 33,000, 35, and 49. And of the people who are employed, 128,000 are employed. How many are unemployed? 6,300. Again, if we add straight across. And if we add straight across here, how many are not in the labor force? 73,581. Okay. So that's essentially how that's going to work there. Again, talking about a contingency table, just adding those columns, adding those rows. And again, if we add all the columns together, these totals, that should equal the amount of people surveyed. If we add all the totals of the rows together, that should also equal the same amount that we have here in 208,720. Okay. All right. All right. So before we move forward here, are there any questions so far? Before we move forward, let me get a group of people. Any questions so far from anyone? Please type no in the chat if you do not have any questions. I am Dylan. I'm doing very well, my friend. I hope you got a chance to check out the 24-hour stream. Or hashtag. Hopefully, I don't know if you had a chance to donate anything, but if you did get a chance to check out the stream a little bit, had a little fun. Saw Ben Foster play a little bit. That was really nice. I gotta say, Ben Foster's got handles, so the guy can dribble very, very well. All right. Okay. So, there we have that. All right, good. No questions here. All right, let's go to the next question here on the handout. We'll come back to this in just a second. All right, what is a marginal distribution of a variable? So a marginal distribution of a variable is the frequency or relative frequency distribution of either the row or column of the contingency table. Now let's take a good look here at this chart once again. So we're going to look at this chart, same chart, okay, same chart that I just have up here. Now if you see here in the book, this chart here is a frequency distribution. Again, we add up the amount of people here in each category. We can add it up via the column, or we can add it up via the row to get our particular totals here. However, let's also take a look here at the relative frequency. Now, relative frequency is something that we talked about also when we talked about frequency back in Chapter 2 or Chapter 3. So this was quite a while ago. So I totally understand if you've forgotten from quite a while ago. Completely understand. But what we have to do here for relative frequency is we're going to take the number in each category here. So for example here, say the 10,179 that are employed and didn't finish high school, and we take that out of the total amount of people that we surveyed, so the overall total of 208,000. And that would reflect our relative frequency here for that particular portion of the table. So what does that look like overall? Remember, we do get percentages and we do get decimals here overall as a result. And again, we're going to do this for each category, so not just the individual, of course, but you get what I'm trying to say here. Now, in this particular case, let's take a look at this table here, which is the relative frequency marginal distribution. Notice that we got 24,395. Now, you're probably wondering where this 24,395 came from. That came from this previous one here. That is the total of the amount of people who did not finish high school, for example. Out of how many people did we overall asked? We asked 208,720. And so we do get a percentage here of 11.7%. We do the same thing for the next column, 61,000 over 208,000. We get 29.4%, and so on and so forth. We do that for every column, and we could do that for every row. taking the total and dividing it by the overall total. Again, if we add up these percentages together in the rows, this should always equal 1 for 100%. Same thing with the columns here. If we add up each of these percentages from each column, they will also add up to 1, which will be 100%. Remember, that is true here for a relative frequency distribution since we are always dealing with percentages. Okay, so just letting you know here, that is what we're effectively doing. Okay, so we have that here just like so. Okay. Any questions in regards to that so far? Any questions? Any questions so far? I know I'm going a little bit slow, but again, I know I haven't written anything down here yet, but you'll see where we're going to go with this, okay? But any questions so far yet? Hopefully it's starting to make sense here. You can visually see what we're going to be doing, but we're going to do an actual practical application, okay? I promise you. All right, so just by looking at... The reason why I use the book examples here specifically, guys, is because the book actually has some very solid pictures and very solid tables that you can reference off of to kind of get the concept down. All right. I wouldn't show it otherwise. All right. Okay, everybody's good. All right. Let's focus on the next question then. What's the next question here? The next question is number 7. What is a conditional distribution? So we have a frequency distribution. We have a relative frequency distribution here for these contingency tables. What's a conditional distribution? A conditional distribution is a relative frequency distribution based on the response variable, i.e. every column. All right? So note these conditional distributions are only issued for every single column that we have here. Okay? Now let's take a look at what a conditional distribution looks like here. And we'll see exactly how this works. As it looks, again, the definition here can be a little confusing. But let's look at what the book has to say about that. Okay, so this table here that you can see on this page is effectively a conditional distribution. Now notice what's going on here. I'm going to point this out here so that way it makes sense. First and foremost here, what we do is we take a look at each individual column here as its own little dude. So basically, we could say, well, how many people did not finish high school? Well, according to our chart, 24,395 people total didn't finish high school in our survey. Well, how many of them were unemployed? 10,179 of them. So now we want to find a relative frequency. We take 10,179 out of 24,395. We get 41.7%. We do the same thing with the next one. Again, take 945 divided by 24,395. We get 3.9%. Again, adding up all these percentages, we should get 100% for each individual column for each relative frequency. So we're taking kind of like a relative frequency distribution for every individual column. Remember, it's every individual column and not the row. All right, so that's why I put this note here. Only for every column. All right, specifically only for that. All right, and then we could do that for every single column here. Again, that's where we get, again, the total here for this high school graduates was 61,000. How many in each category? Just divide by that 61,000. And there you go. You get that second column. And rinse and repeat here for the other two columns. All right. And effectively, that is what a conditional distribution is going to be. Taking a look at that column, says, okay, well, how many people are in this category for that column? Divide, and then you should have a percentage here. In this case, a decimal that reflects a percentage. All right. So that is a conditional distribution. All right. Any questions so far? Any questions about that, about conditional distribution so far? Okay. Now, I totally understand if things are still a bit confusing. Okay. Let's look at it from a numerical perspective. Now, we've seen 3 good pictures here, but you know what? Looking at some pictures of some tables is great, but doing an actual problem is going to help immensely a whole lot more. So let's take a look at an example here, a practical one, and let's do it together. Okay, so we're going to go ahead and do number 7 here. We're going to actually do the exercise here, like you would for the homework. Put this on half and half. Bring this out. Okay, so let's take a good look here at this question here. So, in an effort to gauge how the country's population feels about immigration, researchers surveyed adult citizens. One question was asked: on the whole, do you think immigration is a good thing or a bad thing for this country today? Results of the survey by ethnicity are given in the accompanying table. Complete parts A through F. So let's click on the table. All right. So here is our table. All right, so we're going to write down this table here. Let's write down each part of the table. Here we got 185, 152, 147, 110, 101, 33, 9 and 9 here, 14, 11, and 12 and 6. All right, so this is for non-Hispanic whites. So this is whites, this is blacks, and this is Hispanics. All right, this is what we have here. Great. Okay, so we'll come back to this here if needed. Now, first it asks, how many adult citizens were surveyed? Okay, now in order for us to find this, what we're going to do is we're going to confirm a couple things that will certainly help us out a little bit later as well. Let's go ahead and add up every column and every row. Okay, let's go ahead and do that here in this case. So we're going to use our calculators here. Let's add up all the columns and all the rows. Let's start off with the columns here. So let's say, well, how many whites how many white people were surveyed here? So we have 185 plus 110 plus 9 plus 9. Okay. So if we add this together here, let me check that. Is 10? Okay. So we get 313 here for this first one. Okay. Let's do the next one here. How many black people were surveyed? All right, so we had 278 black people surveyed. All right, how many Hispanic people were surveyed? So 147 plus 33 plus 12 plus 6. We have 198. Okay, so we have the totals here for white, black, and Hispanic here, respectively, for each column. Now, let's go ahead and add each row. So I believe the first one here referred to how many people thought immigration was good. So if we add 185, 152, and 147, we get 484. Next we have 110, 101, and 33. So we have 244. 9 plus 14 plus 12. We get 35. We get 9 plus 11 plus 6 is 26. Okay. Now, if we add straight up and down, or we add across, again with the columns or adding up and down with the rows, we should get the same total here either way. All right, so let's see if we get the same total here either way. 313 plus 278 plus 198. We get 789 here in this instance. Now, if I add the 484 plus 244 plus 35 plus 26, all right, that 2 gets me 789. So I've confirmed my answer here. All right, so the first question CI asks, well, how many adult citizens were surveyed? 789 adult citizens were surveyed, and that's correct. Okay. Then they ask us, well, how many Hispanics were surveyed? Well, we can see here directly on the screen. This is why we add up the columns and the rows. Because this is very easy, we can see that 198 Hispanics were surveyed. Okay, pretty simple when you've already done everything. Okay, questions about Part A? Any questions about Part A? I'm going to do this next part here in just a second. Any questions about Part A? Hopefully easy peasy lemon squeezy so far. All we're doing is just adding numbers, so no biggie. Alright. Nope. Alright. Okay. Now, let's take a good look here at what it asks us to do next. What it asks us to do next is to go ahead and construct a relative frequency marginal distribution. Now, if you notice on the sides here, we have, again, we need 3 decimal places. We have these boxes here, and it should equal to 1. Now, this should be a dead giveaway here that we want decimals here for each individual category. Now, if we want the relative frequency marginal distribution, let's take a look at each row here first and foremost. Now, notice we did do the totals here on purpose, okay? Remember, doing the totals here on purpose will make this problem very, very fast and simple. So we have a total of 484 here, okay? Overall, we have a total of 484 for the first row, all right? So here, we're going to divide that by the overall total of the amount of people that we asked here. So 484 people were employed out of the 789 people, oh, not employed, said it was good, sorry, thinking the last example. 484 people said immigration was good out of the 789 that we actually asked. So our first marginal relative frequency marginal distribution will be 484 divided by 789. And we're going to figure out what that decimal is in just a second. So the next one here will be 244 out of 789. Again, divided by the overall total. We'll take 35 over 789. And then we'll do 26 divided by 789. Okay. Alright, so let's find out what those are. Again, just use your calculator here. Alright, so here I get 0.613. Next I get 0.309. Okay, next I get 35 over 789, so 0.044. Yeah, okay. I have 26 divided by 789. So I get 0.033. Okay, so that's the first set there. Now I want to do every column as well. So for 313, I'm going to have 313 divided by 789. All right. I'll have 278 over 789. And I'll have 198 over 789. We're going to figure out what the decimals for each of these are. And we'll get our relative frequency marginal distribution from these. So 313 divided by 789, 0.397. Then we have 278 over 789, 0.352. And then we have 198 over 789, 0.251. Okay, we have that. Okay, so there we are. We have all those. Again, if I made a mistake somewhere along the way, please correct me. But these should be the values here for this tape. Let's plug them in. Let's see if we got it right. You know, why not try it and see if we got it. So we'll try 0.613. And we'll put 0.309, 0.044, 3, 2.397, 352, 251. All right. So we'll plug those in. And again, if we add these together, we should get 1. If we add these together, we should also get 1. Let's see if we got it. And we did. Nice. Those are definitely the correct answer. Okay. All right. Good stuff. All right. Hopefully everybody got that. Hopefully no problems with that. All right, now it does ask you a follow-up question from that. It says, what proportion of adult citizens feel that immigration is a good thing for this country? And again, a good thing here, just go straight across here. Again, you can follow the relative frequency marginal distribution. Basically, this percentage of 61.3% or 0.613. You could just read the chart for this one, and that's going to tell you the proportion here. Pretty simple. Read the chart, you'll immediately find it. All right, so before we move to letter D, any questions over this previous part? Any questions about this previous part here before we move on to part D? Okay. Hopefully, not so bad. Alrighty. Now, let's look at part D here. Now, part D is kind of on its own here, but it says construct a conditional distribution of immigration policy by ethnicity. So construct a conditional distribution of immigration opinion by ethnicity here. So let's take a good look here. We're going to use this previous table that we have here in order to find out how to do that here. Now again, we have all our totals here for each individual column. Notice that each column here should equal 1. That means that we should have decimals for each one of these individual boxes. So let's say, for example, let's go over this first one here. For whites, we have 313 people here. Now in the first category, we had 185. So meaning to say, what am I going to put here? Well, I'm going to have, specifically here, for that box, I'm going to have 185 over 313. Alright? Because that's for a good thing, and it's in the white category. So I have 185 over 313. Next, I'm going to do 110 over 313. Okay, because again, I have 110 in that second category out of the total of 313 that I have here. And the last two here will be 9 out of 313, and also another 9 out of 313. Now we're going to figure out what these decimals are shortly, but let's set up the others. Next one here, the total is 278 that we figured out from before. Again, this helps us out a lot. So we have 152 out of 278 here. We have 101 over 278. We have 14 over 278. And then finally we have 11 over 278. And it's the unfortunate part is a lot of this is busy work. It takes a long time to do. You just have to do it by hand. All right. Last one here, we have a total of 198. So we have 147 out of 198 for that first category. We have 33 over 198. And then we have 12 over 198. I'm just checking what we have here in each category. And then finally, the last one here is 6. So 6 out of 198 here is what we have for the last part. Okay. Let's find out the decimal equivalents for each of these, and we're going to go ahead and plug those in to each of our answers. Easy peasy lemon the squeezy. Alright, so let's plug these in our calculators here. 185 over 313, get 0.591. Alright, 110 over 313, 0.351. 9 out of 313, that's 0.029. And that repeats again. Alright, next is 152 out of 278, 0.547. 101 over 278, 0.363. And 14 over 278, 0.050. 11 over 278, 0.040. Had to read that carefully. Alright. Finally, let's do the last column here. 147 over 198, 0.742. 33 over 198, 0.167. 12 over 198, 0.061. And 6 out of 198, which will be 0.030. Okay. So these should be all the answers that we should get here for the conditional distribution. Let's go ahead and plug these in. Let's see if we're correct. I'm gonna go across here. And again, if we add straight up and down for each column, these should all equal 1. So if you want to confirm your answer here, that's what it should always equal to. Alright, so adding up straight up and down, these should always equal 1. Let's check to see if we got it. And we did. Nice. Okay. So before we continue moving forward here, are there any questions about the conditional distribution? So hopefully that was as straightforward as I could make it. If you, again, refer back to this video here if you want to review the example here so you can see an example about how that works. So it's a good thing to have replays, and this is just for that reason. Okay. Next. Let's continue to the next part here. So the next part says, okay, just match the graph with the conditional distribution that we have here. That's all it really asks us to do. So again, the blue graph representing good, the green graph representing bad. Next, good or bad, and then no opinion. All right, so let's see which one is the right one here. Well, it's not letter C because everybody said good was, there was more good than bad. So for each one, so that's fine. Let's see. Which one could it be? One of those two is correct. Let's find out which one, right? Just see, it's either A or B here. One of those two is right. difference? Oh, okay. Can't be B because the bar is a little bit higher. So, okay. So it has to be A. Alright. So I gotta pick one of these. I'm like, okay, which one is it? Alright. Now, they'll ask you this last question here for the homework assignment. They'll say, is ethnicity associated with an opinion regarding immigration? If so, how? Choose the correct answer below. So it says, yes, ethnicity is associated regarding immigration. Hispanics are more likely to feel that immigration is a bad thing for the country and much likely less to feel it's a good thing. Yes, ethnicity is associated with an opinion regarding immigration. Hispanics are more likely to feel that immigration is a good thing for the country and much likely to feel it's a bad thing. Or no, they're not associated with each other regarding immigration. All right, so obviously in this case, you want to pick yes. Again, Hispanics in this case, based on the survey results, felt that it was a very good thing to have immigration. So we want to pick B here. They're more likely to feel that immigration is a good thing here in this instance. Check this, and that's correct. Okay. All right, any questions about that? Hopefully that is a whole example all wrapped into one. All right. All right. If there are no questions about that, let's go ahead and want to talk about one more thing here. There's one more thing to talk about. So let's talk about it. So I want to talk about one more thing. That's one more question here on this handout. And that is, what is Simpson's paradox? All right, so Simpson's paradox happens is when in a situation in which two variables have an association with each other, dissolves or goes away with the introduction of a third or new variable. So this can happen here. So let's say, for example, let's use our previous example here. Let's say we're talking about Hispanics and their approval, in their opinion, of immigration. All right, let's say right now there's an association with it in terms of a positive aspect to say that, you know what, they're very closely associated. All right, Hispanics think that it's a good thing to have immigration. But what if we introduced a third variable that suddenly went against the grain and destroyed that relationship? Say, for example, here's something as like a conflict or a war. Maybe opinions can change for whatever reason because there's a war going on. You know, it could be literally anything, but maybe it's something as big as that. And then suddenly opinions magically change, and then you take the survey again, and suddenly that relationship isn't there anymore. That could be the introduction of the third variable there that could destroy the relationship between the two that was already there to begin with. All right. So, if you're taking a good look here, what researchers like to do is to figure out why this third variable has such a strong effect. I know my example is super simple, but let's say there's an introduction of a third variable, and maybe in some circumstances, that third variable just destroys the relationship between two things. And maybe it's a unique or special circumstance. So maybe it's a once in a blue moon kind of thing. So it's like, do you have to place a lot of importance on that third variable? You have to worry about that third variable or not? You can say maybe in this circumstance you do, but maybe it's not that important because it doesn't occur all the time. You know, maybe a very specific, unique set of circumstances just causes something to just not work anymore. And that, I think, in reality, in just everyday sort of thinking, can easily happen. Okay, so, but, you know, if you're looking for something more concrete, you know, if it happens more often than not, then maybe that third variable needs to be taken into account. So Simpson's paradox is there to just remind ourselves, you know what, there's always that possibility that can always destroy a relationship if it presents itself. So you think about all possibilities when you do statistics, oftentimes. All right. In any case, that in a nutshell, ladies and gentlemen, that in a nutshell is section 4.4. That in a nutshell is section 4.4. Does anybody have any questions? about section 4.4. All right. No? All right. Please type no in the chat if you don't have any questions. All right. Okay, so, ladies and gentlemen, let's talk about what has just happened here. Ladies and gentlemen, let's talk about what just happened here. We are now effectively done with the textbook. There is no more new material to do. Yay, you guys made it to the end. All right, great job. You guys have finally made it. Yeah, all right. We made it to the end of the textbook. That is it. There's no more new material after today. All right, no more new material after today, if you can believe it. That's amazing. We finally made it all the way here. Santa's like, yeah. Like, yeah, I don't disagree. I don't disagree. However, as I mentioned here last week, I mentioned here that I have a very large announcement. And this part is definitely true. I do have a very big announcement for you. So until I felt it was time, when we finished up the material, then I would be able to make this announcement. So I kind of got to thinking last week. I was thinking, you know, you guys are stuck in with this for the whole course of the semester. You guys, a lot of you guys who come out, you guys come out to every stream. You guys make this fun, you make it exciting. All right? You guys we have a great time together. I'm like, you know, I could be evil. I could be benevolent. I could be evilly benevolent or benevolently evil. I said by nature, I'm a mathematics professor and I'm evil. But I'm like, maybe not. Or maybe I'm just talking out of my rear end. But yeah, that has nothing to do with what I wanted to say. Right, anyway. Anyway. What I really wanted to say was... You're like, get to the point, shut up. Okay. I get it, alright. I get it. Let me switch to the main cam. Alright. Like, get to the point, shut up. Alright. What I am going to introduce now, ladies and gentlemen, is what I'm going to introduce now is what is going to be referred to as the Great Reset. We are now in the midst of the Great Reset. Now, what is the Great Reset exactly? Well, ladies and gentlemen, earlier today, what I have effectively done is I want you to think about certain things. Think about the homework assignments and the tests that you've done. Maybe you didn't do so hot. Maybe you didn't do so great. And I've effectively done... What the Great Reset says is that I have changed all the due dates for all the assignments and all the tests to the very last day of the semester, which is the 16th of December. The last day of the semester is 16th of December. So, everything is now wide open. Yeah, congratulations, all right? So you have a chance to redo your homework assignments that you missed. If you want to improve your homework grade, you want to improve your test scores, if you felt you didn't do so hot, you have a chance to do so. If you haven't done, look, anything and everything is now on the table. Everything is up and ready to go. All right? Anything is up and ready to go. So everything is now wide open. If you want to improve your grade, now is the time to do so. We have less than a little bit over 3 weeks left to go. So again, Let's go, says Dylan. There you go. Yeah. So, yes, everything is now brand new. It is wide open. So, I would take full advantage. Don't wait until the last minute to do your things. It's time to take full advantage. Everything is now due at the very last day of the semester, December 16th at 11:59 p.m. Everything is due. So, all the previous homework assignments, all the previous tests, the practice tests, do those practice tests, guys. That's super important. Everything. I have reset everything in terms of a due date. And now this is your time to shine. All right? So that is, I've decided to kind of do that last week for instance. Like, yes! Thank you. No problem, no problem. So that is PogChamp indeed. So that is my announcement to all of you, is to now you have a chance to do even better or improve upon the scores that you already have. So now you can't come complain to me and say I wasn't given enough time. I've given you enough chances and enough time of which to finish anything and everything. So now I've reopened things, and hopefully you'll be able to get the grade that you want here at the end of the semester. For those of you kind of lagging behind, hey, this is your chance. Don't waste this opportunity. Get on it as soon as possible. That means not at the end of the semester. That's not as soon as possible. So, Christmas came early this year. This is true. It's true, Dylan. It did. Your last class is on the 16th as well, Dylan? Ooh. You know I'm flying in on the 18th there, by the way. The very next day I'm going to the airport. They will open a tin of dog food this time. No, but seriously, like I like the 16th comes, I gotta grade that night, and then I'm hopping over to the airport, getting on a plane, and coming straight to England. That's what's happening. It's happening. It is happening, Dylan. This I assure you. Now, I know you'll be off in another place, but that's okay. That is not a problem. You'll still be able to see me when you come back, so. Yes, that's the attempt. That is the attempt, my friend. That is the attempt. So I'm gonna see if everything plays out. I will be able to land in London at 7 in the morning, and then be able to get to my lodging, and then I can get to the game on time. Yeah, I'm gonna have a long couple of days. That'll be worth it. I don't care. It's gonna be worth it. I don't care. I'm gonna try my best. Try. All right, any questions, ladies and gentlemen? Any questions? I got one more thing to talk about here. You should be going back down to London on the Friday? Okay. Yeah, I'll be there. I'll be flying in on the Saturday there, so. Any other questions before I have one more thing to talk about here, legitimately, so. No bad. Right. Okay. Now, I do want to talk about one more thing here with you guys, and that is talking about the rest of the lectures here. Now, we are still going to have online lectures, okay? So, just because we're done with the new material here doesn't mean that the lectures will stop. Effectively, what we're going to be doing here, starting from the next class next Tuesday, is I'll be taking any and all of your questions. So if you have questions over homework assignments, you have questions over practice test questions, you want me to do examples for any topics that you're confused about, you ask me, and we're going to do that. That will be the first and most important priority here from every lecture going forward until the very end. And remember, again, if you have a bunch of questions, just bring it to me during class time, and I'll be more than happy to answer it for you at any time. Okay. During the class time, that's perfectly fine. You can of course ask me outside of class, but still, you're like, hey, I want you to do this problem. Can you try this problem out? What's the answer to this? Hey, show me how to do this. That's fine. We can go over that. That's not a problem. All right. So any of those things, that's perfectly cool. That's what we're going to be doing the remainder of the time. If we don't do any of those, then we can play video games on stream, or I don't know, shoot the breeze or do something. So there you go. Is there a practice final? Great question. The answer is no. There's no practice final, because what I effectively did was I took all the questions for the final exam are from the practice tests. So if you do the practice tests, I just took a smattering of questions from each of the practice tests and I made it into a final. So if you know what to expect on the tests, or the practice tests, because they're the actual tests for the actual unit tests, then you'll know exactly what questions will appear on the final, pretty much. So it's as transparent as it can get. That is why there's no practice final. So that's why I highly suggest do the practice tests, because it will prepare you not only for the real test, but it'll also help you to prepare what questions will be on the final. All right. So that's essentially how that's going to go. How many questions on the final? That's also a good question. I don't know. How many did I put on the final? I don't even remember. Some amount. An amount bigger than one. Okay, let me see. All right. Let me stop fooling around. Let me answer your question here. Yeah, prior exams have been 30 questions, but the final, I know the final is not. I think I put more than 30 questions for the final, but I'm gonna let me find out, because let me answer that a little bit more diligently for you. I put 45 questions. 45. So I put 45 questions for the final exam. So it's like a test and a half. So not too crazy. And you get retakes and stuff, so that should be fine too. Anything else, guys? Ask me whatever you like. If you guys got anything else, I'll be more than happy to take your question now. It's not a problem. You guys are all right? So far, so good? All right. Well, I'm glad that you guys were able to make it out here today. Dylan, my friend, I need to ask you if you're going to go to Arizona or not for winter vacation. I have no idea. I remember you mentioning that you might, but I don't know the answer to that question. Only you do. So, all right. Well, while I wait for that, hopefully, if he's still there. Okay, ladies and gentlemen, I want to thank you all. Nah, you maybe going to France. Okay, just let me know if you're going going to a place during that vacation time. So if we have a chance to meet up here, then certainly we can certainly do that. I would love to do that, my friend. Love to meet up with you either at a game or in Liverpool, whichever one. So, all right, ladies and gentlemen. I want to thank everyone here for coming on out here to the stream. America next year likely. Very good, very good. Well, and I'll be here for you if you're gonna come over to America. Come by Chicago sometime, and show you a good time. All right. Thank you very much, everybody. I really, really sincerely appreciate it. All right. At a game for sure. Yeah, there you go. Thank you very much, everybody. Thank you so very much. I love you all. You all are fantastic, okay? I hope everyone here has an absolutely fantastic Thanksgiving holiday. All right. Best mate on my course is from Chicago originally. Well, there's your OG right there. Oh, man, there you go. Gotta respect. Gotta respect. All right. Have a wonderful Thanksgiving, everybody. Please spend time with your family. Eat some turkey, eat some mashed potatoes if you eat mashed potatoes with some gravy. Okay, have a wonderful holiday, everybody. I hope you enjoy yourselves, and we will see you again next Tuesday. Okay, next Tuesday, 1 week from today. Thank you so very much. Again, get on that. Thank you very much. Start that work, get that stuff done, and have a wonderful time with your families. All right, take care, everybody. We will see you all later next week. Have a great one, everyone. See you later. Take care, everybody. All right, and as always, stay safe, stay healthy, and most importantly, stay sane. See you later, everybody. Have a great one. Take care. Bye. Bye, everybody. See you, Dylan.